We are going to talk about sorting algorithm, focusing mainly on bubble sort. So after going through this part of lesson, we will learn what is sorting, why sorting, what are the different types of sorting techniques. Then we will discuss bubble sort, and then time complexity of the bubble sort. Sometimes it may require to arrange the elements of a list or data in certain order, either in increasing order or in decreasing order. This may improve the readability of the data, or it may help to search or extract some information quickly out of data. So, sorting is arranging the elements in a list or collection either in increasing or decreasing order, depending on some property. But one thing you should remember, that list must be homogeneous, that is, all these elements will be of same types. For example, you can sort the integer elements. Here, in this portion, if the data are 7, 4, 8, 12 and 9, after sorting, it will be in this order 4, 7, 8, 9, 12. Or we may sort the string data. For example, if we sort read, write, play, sing, then it will look like play, read, sing, write. One of the main advantages of sorting algorithm is that it may improve the time requirement in searching some element from a large set of data. For example, if a list is in unsorted order and we want to search some element from the list, we have to apply linear search, which requires almost n comparison if the list size is n. So, if there are 2 to the power 32 elements in the list, we require, and each comparison require 1 millisecond time, then we require 2 to the power 30 millisecond time maximum if the element is not in the list. Then, whereas if the list is in sorted order, then we can apply binary search, which require most log n raised to comparison. So for the same set of data elements, that is, the list contains 2 to the power 32 elements, we require log 2 base 2 to the power 32 millisecond time, is 32 millisecond, which is much less than the previous one. There are so many sorting algorithms are available. They are bubble sort, selection sort, insertion sort, quick sort, merge sort, heap sort, radix sort, and much more. Also, some research is going on to find out some efficient sorting algorithm. But in this course, we discuss mainly bubble sort. In the bubble sort technique, we compare each elements of an array with its neighbor to the right. If they are out of order, then swap them. This puts the largest element at the very end. The last element is now in the correct and final position, and then repeat this process until all elements are sorted. Now we will discuss bubble sort with an example. Here we have taken 2, 7, 8, 5, 4. First we compare 2 and 7. Here 2 is less than 7, so no swapping is required. Then we compare 7 and 8. Again 7 is less than 8, so no swapping is required. Then we compare 8 and 5. If 5 is less than 8, so we swap 5 and 8. Then we compare 8 and 4. If 4 is also less than 8, so we swap 4 and 8. Now 8 will be in the last position, and this will be the result of the pass 1. So after pass 1, the result of pass 1 will be taken as an input to the pass 2. Here again we compare 2 and 7. So again 2 is less than 7, so no swapping is required. Then we compare 7 and 5. 5 is less than 7, so we swap 5 and 7. Then we compare 4 and 7. 4 is less than 7, so we need to swap 4 and 7. So after this pass, 7 and 8 will be in the sorted order, and the remaining 2, 5, 4 will be in the unsorted order. And then in this way, taken as an input to the next pass. So again we compare 2 and 5, and 2 is less than 5, so no swapping is required. Then 5, we compare 5 and 4. Again 4 is less than 5, so we need to swap 4 and 5. And after this pass, 5, 7 and 8 will be in the sorted order. Next we compare 2 and 4. So 2 is less than 4, so no need to swap. So now after this pass, the array will be in the sorted order 2, 5, 2, 4, 5, 7 and 8. Now if we write the algorithm, then we look like the pseudocode. If we see the pseudocode, in the inner loop, if each element ai is greater than ai plus 1, then we need to swap ai and ai plus 1. And here the outer loop is, when it will be determine the pass. How many pass? This will be operate. The next, if we see the time complexity, the outer loop here is executed n minus 1 times, which is almost close to n. The inner loop is executed n minus 1 times fast, and then it will linearly dropping to just once. So on an average, the inner loop will be executed n by 2 times. So the number of comparison will be, and result will be n into n by 2 plus k. So that is the order of n square. Thank you.